Okay, we're looking at problem 64 from chapter 12, University Physics. So we have a piece of ice cube placed in a full glass of water. And so the question is asked is that, so what's the volume of water that the ice cube displays? And part B, when the ice cube has completely melted away, so any water would overflow. So we have a glass of water filled to the rim, and there's a piece of ice floating in the water. And so the question is asking for the volume of water displaced, as well as the interesting question, when the ice melted away, would it cause the glass of water to overflow? All right, so here's an illustration of what's happening. So we have, let's say, a glass of water filled to the rim, and there's a piece of ice placed into the water. And we know that ice flows on water, so and part of it is submerged into the water, and part of it is above the surface of the water. So the ice has a mass of 0.0164 kilogram, and the volume of water is 420 cubic centimeters. So what volume of water the ice would displace? And so we go ahead and apply Archimedes' principle. Because the piece of ice is floating on the water, so the weight of the ice is going to be balanced by the upward pushing buoyant force. And so from the buoyant force, we can obtain the volume of the water displaced by the piece of ice. So setting the buoyant force, Fb equal to the weight of the ice. And so we have the mass of the ice times the gravity g, which is going to give you the buoyant force, which is expressed as the density of the water times gravity g times the volume of the water. So notice that is the density of the water and not the density of the ice. And so we're looking for the volume of water displaced by the piece of ice. And go ahead, we can solve for that. Knowing the mass of the ice, it's given by 0.0164 kilogram. And divided by the volume of water, which is 1,000 kilogram per cube. And we have the volume displaced by the piece of ice, which is going to be 0.0164 times 10 to the opposite 3 meter cube.